Hi, I'm so excited to check your submissions. Let's do it.
Okay, boomers, if you have questions with quality, post it on our subreddit, no matter your entity. I may or may not check it in the next episode of LATITY.
I want to see Mehdi debunk this. Oh. The eyes of an electrician after being zapped by 14,000 volts of electricity? There is nothing to debunk. Is it real? Oi, this seems real. I look okay. Yeah, let's not do that. 800,000 volts tower generator. I don't think there will be any eyes left at that point. Does this damage the battery and drains it fast? Oh, it's making fire by making a wire very hot. Taking a very thin wire, pretty much just shorting the battery with it, which makes the wire very hot and it makes fire. Let's give it a try. For some reason, I kind of doubt if a single AA battery has enough power to make a wire glow. According to the video, we cut a piece of multi-strand wire, try to split the wire jackets from the middle, pull it open, only keep one of the strands and cut the rest. Then we can easily pull it out of the wire without taking it all the way out. Strip the other side of the wire. The point of keeping thick ends of the wire is that they are very low resistance and won't get hot. Only this very thin single wire gets hot. I guess we take a piece of napkin, wrap this piece of wire around it. Now let's see if it actually heats up. Oh, there's smoke coming out of it. No flames though. Oh yeah, it started glowing. What if I try another piece of napkin to set on fire? Come on, man. Well, it didn't really set anything on fire. My battery is getting hot and, well, I think it is possible, but not that easily. Let's see roughly how much current is running through the wire. 4 amps, not bad. And the battery is slowly discharging, I guess. Ow. Now I'm pretty sure that guy had a bunch of fuel on his stuff that started burning so rapidly. Yeah, I guess it is possible if you are in the woods and don't have a match with you, but have a spare AA battery from your flashlight, have a spare piece of wire, have some wire cutters, and don't mind killing the battery of your flashlight. Instead of killing all your batteries and setting the jungle on fire while you wait for the help to arrive, I suggest you visit my sponsor's link brilliant.org/ElectroBOOM and start learning new knowledge on their app for free. Because you can't just hammer complex information into your brain, you need Brilliant's interactive and effective way to learn and maintain it. More at the end. Cause of giant blackout in Spain, Portugal and France. Now let's test the breakers. Sorry about that. Why use one outlet when you could use 2 halves? Huh. I guess it's fine to plug it like that. Do we have that possible here? Look what I found! It is the same thing. You can plug something between 2 outlets like this, which is fine. You're getting the same voltage to the device and you're wasting one of the outlets. But if the plug had an earth, you wouldn't be able to do that. You had to go over its own outlets. It seems like they exactly spaced the outlets so you could do that, plugging something between the 2 outlets. But there is no application for it. Why did they do that? Is there a point? Let me know in the comments. I bet there isn't. Then, if you're the designer of one of these things, why did you space them exactly such that you can plug between the 2 outlets? Huh? Hey look, I learned a neat trick. Instead of plugging into the right place, I can plug between the 2. So what? I guess it's for rich people to show they can do anything with their money. When a stick is placed across high voltage, this happens. Why? Well, first of all, why do you have such powerful lines running so low on the ground that somebody can trip on it and get cooked? If it's cooking a piece of wood, it's gonna cook you as well. This is a fresh piece of wood, which means it still has some conductive liquids in it and hence all the arcing and stuff. Exactly how your body is full of conductive liquids. Why are those wires so low on the ground? Maybe someone in the comments can tell me why they made it like that. The question should be, why is there an exposed high voltage line at knee height? Exactly. I have so many questions. LATITY 2.0 in RHE making. Student built a $2,000 working fusion reactor in their bedroom. It is super annoying to me when I see a title like that. Do you know how many billions of dollars they are investing to make a fusion reactor and someone just makes it in their bedroom? Hey, I made a fusion reactor! The point of a nuclear reactor is to generate more energy than it is using, so you can use it as a power source. This ain't it. You know, fusion reaction is when you join two hydrogen atoms to create one helium atom and generate a ton of energy in the process. Something that happens in the sun. Did you make a sun in your basement? It is a very hard process to replicate. Just look at the experimental setups they make to attempt making such fusion reactions. Is your mom proud of your fake achievement? And all these people are making are one of those plasma balls. Plasma balls. Working fusion reactor in their bedroom. Thanks to my DIY soldering iron, I experienced 220 volts. What in the world is this? Did you run out of electrical tape? Why didn't you go all the way to the top? Of course, he changed the output coil to only a few turns, which means it's very low voltage, high current, and is safe. Good for a soldering iron, but next time, use more electric tape. Let's give it a try. See, I have pulled one of these transformers out of the old wall outlets. And since these guys typically lower the 120 volt to whatever voltage you need, like 10 volt or something, the thicker wire is the secondary of the transformer. So we try to pull the wires out of the secondary. I'm trying to take the wires out without breaking them, because you never know when you might need these wires. Maybe I want to wind a new Tesla coil with it later. Now we run a single turn of winding through the secondary of the transformer. It was only one turn in that picture anyway. We plug in the primary of the transformer. Ouch! Damn it, the earth is... Did I pop the breaker? Yeah, it was popped. That's why we don't do this at home. We do it at Kuman's office. We are a bit more careful and we plug in the primary. And we should be getting a low voltage from the secondary. Let's see how much it is. What we have is... 64 millivolts only? That's not enough to heat any elements. I put the meter on the ammeter and shorting the output. There is 0.6 amps through it, 0.7. Yeah, I would say using... Got copper plated again. Yeah, I would say my transformer is probably too small for this. I have drawn a ton of current from larger transformers and melted stuff with it. Perhaps the guy's transformer was larger, fewer primary number of windings, which makes it less resistive. But I would still think you would need more secondary turns too, because you do need higher voltages to draw higher currents. Am I banging this wire to my microphone? There we go. Reason British plugs are the best. Oi, you can use them as a bottle opener. That's why they're large. It is not just UK plugs, they're all designed to also act as a bottle opener. See? Anything is a hammer if you put your mind into it.
Your commute could end up powering the train you get on, or even the city you live in, thanks to these new turnstiles. Every passenger that passes through these generates clean energy, which can be used to power all the stuff passing through them, and the movement of the turnstiles generated clean energy. This is so clever. They did this for 2 days in Paris last year. 27,000 passengers passed through these turnstiles, generating 2,000 watts of energy per day, just from getting on the train to go to work.
He did say the unit generated 2,000 watts in 1 day from 27,000 people passing. Let me do some quick calculations. Energy is equal powers times time. So 2,000 watts times 24 hours times 60 minutes times 60 seconds is equal almost 173 megajoules of energy. 27,000 people passed, which means energy per person is equal 173 megajoule divided by 27,000, which is almost 6,400 joules. Let's say everyone took 2 seconds to pass through this thing. So power for each person is 6,400 joules divided by 2 seconds, or 3,200 watts. Considering, say, a large Mikita miter saw draws no more than 1500 watts, that claim is false. No one would be able to go through those gates with such ease. It would be more like... I keep seeing these on every home here. What are they? Oh, these are wire balls. I have no idea what these wires are. Where do you live? Let's see what people say. Wire nuts? It's a service loop for coax cable. Water can't run uphill, so the loop prevents water from following the wire into the building. I haven't seen these around here, and I'm sure it rains in Vancouver. Spring is here. Oh, look at those wires sprouting. Touch 380 volt wire. Ow. Ouch. I did the exact same thing with 220 volts. Are these live? This is like a male connector. Shouldn't it be female if it is live? Somebody did something wrong. Here's a neat physics lesson.
Up here we have a 345,000 volt line that we built. So you have a big force field essentially going around these conductors, and it induces a voltage in that field. This is a perfect conductor, it's a fence. If you look closely, whenever I move this chain, you see little sparks. You see that?
Oh yeah.
This fence is getting an induced voltage off of that power line.
I guess the main question is it the electric fields or the magnetic fields? The generated magnetic fields are looping around the wire, so it means that if you are creating any coil, it should be in the same plane as the wire so that the magnetic fields can pass through it. It is important to remember that the sum of three sine wave phases, 120 degrees out of phase with the same amplitude, is 0. So, if you have a three-phase power line like the one back there, and they are so far that the distance of each wire to you is almost equal, it means that the electromagnetic fields generated at your location are almost adding up to 0. But let's assume it's one of those huge towers that all the wires are far apart and you're so close to one of them. Let's give it a try. I made a cross and I want to join the K-pop demon hunters. I want to make a big coil. I have some wires and I'll run it around my cross. I had enough wires for 4 turns only, and its inductance is like 40 microhenries. Let's see if it can pick up any power lines. So this is what I'm doing. I made a single loop of wire here connected to my auto transformer there, and I'll turn it on and run close to 30 amps through it. Well, 34.5 actually, and then I'll bring my coil close to it to see how much voltage I'll induce into it. You might be saying the voltage here is very small compared to the super high voltage of like 500,000 volts on the power lines passing above. But you must remember, the magnetic fields only have a relation to current, not voltage. If I give this the best chance and put it directly on wire, all I read is like 30 millivolts. Even if I give it a better chance, making the wire loop the same size as my coil and put it under, all I'm seeing is like close to 60 millivolts. So imagine, even if there was 30,000 amps running through the power line, all I would get from a straight wire would be like 25 volts. Well, that's barely any voltage induced to be able to create any magnificent arcs like we saw in the video. Damn it! I'm burning the room. Look at their carpet. Oh no! Damn it! Oh no. So I guess it's safe to say that the magnetic fields cannot generate super high voltages across the surrounding conductors to create those arcs. Then it is the electric fields of super high voltages in the wires. So say hello to my fresh new Van de Graaff machine that makes much less noise, but still very high voltages. Although it can go upwards of 200,000 volts, it cannot sustain much energy compared to those power lines. So let's say this is like a high voltage power line, and this ball that is not connected anywhere is like any floating metal close to the power lines. And you see, there is no arc between them, but if I bring my grounded finger close to the ball, you hear them? Ow, ow. I don't know if you can see the arcs jumping to my finger there, but you can definitely hear them. Ouch. Ow. Ow. So although there are no direct arcs from the power lines to the surrounding conductors that are far away, because of super high voltage, they will push and pull charges through the air, through the conductors, and if they are close to ground, we will see arcs jumping between them. Fun things happen under the high voltage power lines. Should go under one of them soon. What the? What, a motor and 2 batteries? Well, this is clearly fake. Although one can assume that you can make such a trick using a monopolar motor's structure like I've made in one of my old videos, I would say these batteries accelerate so fast to such high speeds and there is no kickback that I suspect there is some motor under the table turning them. Who does it better? Damn it! At this point, I might as well just give her my channel. Fixing light bulbs the amateur way. What is he doing? Cutting those. Hopefully they don't have power. Oh. Did you hear that? Someone at the end goes, did you cut the wires when they were live? I mean, it seems like the guy clearly knows there's power in those wires. Why is he cutting them then? Just to turn off the breaker, man. Yes, I suppose you learn by interaction and experience, but why put your life at risk when you can learn everything you need safely through my sponsor Brilliant? There, interact with science, math, programming, or data analysis without breaking your back or bank. You keep wondering why everyone is better than you in math and stuff. Perhaps because you never had a good teacher. I remember I had a classmate who always got bad marks in math. I just spent 2 days helping him and in the next exam, his mark was better than mine. That's why I never taught him again. But Brilliant will never abandon you. It will never let you down. It is on your computer or phone to help you. With thousands of visual and interactive lessons at any level you need to start and progress from, you are sure to find what you need. And with their focus on high quality lessons and interactivity, which is the best way to learn, you are sure to succeed at it too. Visit my link brilliant.org/electroboom and start digging into this treasure box for free. Because you need to learn, and as your father, I want you to be the smartest version of yourselves. So with my link, stay subscribed to Brilliant's annual premium plan at 20% off forever. And thank you for watching. Da-da-da-da-da. 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 Da-da-da-da-da.